Paper number 9. Hmm? Find the equations of the diagonals of the parallelogram with the equations of the sides. Right. Let's say, suppose we have the parallelogram. Right. I'll take the vertices as A, B, C, D. 3x minus 2y minus 1 equals 0, this side. Then its parallel side should be having the first two terms same way. It is 3x minus 2y minus 2, therefore 3x minus 2y minus 2 equals 0. And I'll take this side as 4x minus 5y minus 6 equals 0. And this is 4x minus 5y minus 3 equals 0. Right. Then asking to find the diagonals. The equations of the two diagonals. One diagonal is this. Right. I'll take this point C as x naught, y naught. Then this point C lies on this line and this line. Therefore, this x naught, y naught should satisfy this equation and this equation. Then I can write first one 3x naught minus 2y naught. 3x naught minus 2y naught equals 2. Also, let's see point C is on this line. Then this x naught y naught should satisfy this equation 2. Then we get 4x naught minus 5 y naught equals 3. Right? Let us take this as number 1 and number 2. Right. Now, this line, if I take as line L1, that line passes through the intersection of this line and this line. So therefore, I can write the equation of this line how this line plus lambda times this line equals 0. Okay, where lambda is a parameter. Right. In L1, we can write how 3x minus 2y minus 1 plus lambda times 4x minus 5y minus 6 equals 0. What is this lambda? Lambda is a parameter. But you know, this line is this, it passes through the point C. Therefore, this x naught y naught should satisfy this equation. Okay. Yeah. Then what happens is we can put x naught y naught here. 3x naught minus 2 y naught minus 1 plus lambda times 4x naught minus 5 y naught minus 6 should be equal to 0. For this part, 3x naught minus 2y naught equals 2, y number 1. For this part, 4x naught minus 5y naught is 3, y number 2. Okay, then here we get 2, and here minus 1, 2 minus 1 is 1. Lambda within bracket, 3 minus 6 is minus 3 equals 0. Then lambda is 1/3. Lambda is 1/3. That lambda we can put where here. Thereby we can find the equation of L1. Right. Therefore the L1. Write that here. No. Okay. Therefore L1 we can take. Right. Substitute here 1/3. 3x minus 2y minus 1 plus 1/3. 4x minus 5y minus 6 equals 0. Multiply by 3. Here 9x plus 4x. 13x. Here minus 6y. Here minus 5y. minus 11y, here minus 3, here minus 6, minus 9. Correct, no? When you multiply this throughout by 3, 9x, therefore x, 13x, minus 6y, minus 5y minus 11y, minus 3, minus 6, minus 9. That way we can find the equation of this L1 very easily. And BD also we can take in the same way. BD I can write I take this point D as x dash y dash. Then another two more equations we can write. This x dash y dash is on this line as well as on this line. Okay. Then I can write this way 3x dash minus 2y dash is equal to 2. Number 3, 4x dash minus 5y dash is equal to 6. Number 4. Then the equation of BD, if I take this as L2 we can write this equation plus mu times this equation minus 3 equals 0. This way we can write. Alright, this line x dash y dash is on this line. Therefore, this x dash y dash should satisfy this. Then I can write what is this mu? Mu is a parameter. Then 3x dash minus 2y dash minus 1 plus mu 4x dash minus 5y dash minus 3 is equal to 0. 3x dash minus 2y dash is there 2. This is 2 minus 1. Mu 4x dash minus 5y dash is 6. This is 6. Right. Then here we get 1. 3 mu equals 0. Mu equals minus 1/3. Then we can substitute that mu value over here, and we can find the next diagram. Okay. Right. So then all right. Now we can take that L2. Therefore, L2 equation we can write 3x minus 2y minus 1 plus mu is minus 1/3. Then I write here minus 1/3. 4x minus 5y minus 3 equals 0. Multiply by 3. Here 9x minus 4x. It's 5x minus 6y. Here plus 5y minus 6y plus 5y minus y. Here minus 3 plus 3 will be 0. This is the equation of the next diagonal L2. This is how we take the equations of the diagonals. Right. Second question, limit question. Right. Second question, limit 1. Limit x going to 0. Two times root 3 sin x plus 5 by 6 minus cos 6 plus 5 by 6. Root 3 times x, root 3 cos x minus sin x. Right. Now, I divide this term and this term by 2 and meantime multiply by 2. Then this expression won't change. Limit x going to 0. Then this will be 4 sin x plus 5 by 6 into this root divided by 2 minus cos x plus 5 by 6 into half. This way, right? Now I can write this root 3 by 2 cos 30 cos by 6 is half as sin pi by 6. Sin x plus 5 by 6 cos 5 by 6 minus cos 6 plus 5 by 6 sin pi by 6 divided by root 3x into root 3 cos 6 minus sin x. Yes. Then you can take here out. If you take this angle as your angle A, this is also angle A. This is B. This is also B. Then here we have sin A cos B minus cos A sin B. Sin A cos B cos A sin B means sin A minus B, right? Then I can write it this way. Limit x going to 0 4 times sin A minus B. A is x plus 5 by 6 minus 5 by 6. Okay. Then this root 3, I write below this 4 like this. This x I write here, and this part I write next. 1 over root 3 cos 6 minus sin x. Right, now we can put here this and this, you can cancel down. Right, 4 over root 3. The limit x going to 0 we can apply separately. This is sin 6 by x. Limit x going to 0 here. Root 3 cos 6 minus sin x. This is 1. Here when you put x 0, this is going to be 0. Cos 0 here 1, giving only root 3. No? Right. Then 4 over root 3 into 1 over root 3. This gives us 4 over 3. That's the limiting value. Number 3, asking to find the general solutions. Right. Asking to find the general solutions. Number 3. 2 sine 3x into sine x equals 1. This 2 sine A sine B form. 2 sine A sine B, that product formula we can write 2 sine A sine B product formula, you can write cos A minus B minus cos A plus B. This way. We apply that we are here. Taking this as your A and this as your B. Then we get 3x minus x is 2x minus cos 4x equal to what? This cos 4x we write using cos 2a formula, 2 cos squared 2x minus 1. This way. Using cos 2a formula, right? That is using cos 2a formula. Now, we get here cos 2x, 2 cos squared 2x, here 1, here 1. These two we can cancel down. Take cos 2x out. 1 minus 2 cos 2x. Now we get 0. Equate this to 0 and this to 0. Right, here we can write the general solution. Here we can write the general solution, right? Right. Cos 2x 0, mean I can write cos 2x equals cos pi by 2. 2x equals 2 in pi plus 2 minus pi by 2. X you can write dividing by 2 this way. What is this n? N is any integer. Come to this with cos 2x. It is half. Or cos 2x is half. Half you can write cos pi by 3. Then you can write 2x equals 2 n pi plus 2 minus pi by 3. X equals n pi plus 2 minus pi by 6. N is any integer. This way we can take that. Right. Fourth one next. Right, fourth one. The ellipse C parametrically given by this way. Ellipse is like this. This is the ellipse. X-axis, y-axis. Right. Ellipse is C. Okay. Parametric coordinates. That means if I take any point on the ellipse as xy, the x coordinate is given by 3 cos 30. Y coordinate is given by 2 sin theta. 3 cos theta is x coordinate, y coordinate is 2 sin theta. Show that the equation of the perpendicular drawn to this ellipse at P. We take a point P here. That point P has the coordinates 3 cos theta and 2 sin theta. 2 sin theta. This is. Here a perpendicular is drawn to this ellipse. This is the tangent. Okay. Perpendicular is this. The equation of this only asking. Then we will first find. Here theta sin inverse 3 by 5. This theta is sin inverse 3 by 5. Theta sin inverse 3 by 5 means taking sine to this side, sin theta is 3 by 5. Then by drawing a triangle here for sin theta 3 by 5, right angle triangle, opposite is 3, hypotenuse is 5, then adjacent is 4. Then we can write cos theta. Cos theta adjacent by the hypotenuse 5. Right. Now, here the coordinates really 3 cos theta and 2 sin theta at the point P, the coordinates. Then we can find the coordinates of point P in real numbers. Right? Then point P is really 3 cos theta multiply cos it by 3, 12 by 5 here. 2 sin theta multiply this by 2, 605. Right. Now, at this point, we need to find the gradient. Right. Then if we can find the gradient of this tangent, the gradient of this perpendicular going to be take reciprocal of m and multiply by minus sign. Then using this point P 12 by 5, 6 by 5, we can find the equation. Now, to find the gradient at any point, gradient means dy by dx. We differentiate this and this with respect to what? Theta. X equals 3 cos theta. Y equals 2 sin theta. Dx over d theta minus 3 sin theta. The derivative of cos theta is minus sin theta. No? And here dy over d theta. 2 cos theta. The derivative of sin theta is cos theta. By chain rule, you can write dy over dx as dy over d theta multiplied by d theta over dx. Dy over dx is therefore dy over d theta is 2 cos theta, and d theta over dx is a reciprocal of this. 1 over minus 3 sin theta, correct? No? Dy by d theta 2 cos theta. D theta by dx means the reciprocal of this, right? Then there we get dy by dx is minus 2/3 cos theta by sin theta, right? This is the gradient at any point on the ellipse, but we need the gradient at the point P. At the point P, to find the gradient, we can put the coordinates of P there. It is 3 cos theta. Yeah. Then we can write we need dy by dx at that point is minus 2/3. At that point cos theta is 4 by 5. Here 4 by 5. Sin theta 3 by 5. This and this we can cancel down. Dy by dx we get minus 8 by 9. Right, so then the gradient of this tangent is this. Gradient of the perpendicular going to be take the reciprocal of this and right multiply by minus sign. Therefore, the equation of the perpendicular. Outtake. We write y minus y naught equals m times x minus x naught, this formula. X naught, y naught, this coordinates. M is the gradient of this perpendicular. Then we can write y minus y naught is 6 upon 5. Gradient, take reciprocal of this and multiply by minus sign. X minus x naught 12 by 5. Right, now when you simplify this, we get the answer. Right, now first we multiply this by right, multiply by people 5 here, we get 5y minus 6, right, 5 minus 6. When you multiply this by 5, we get 45 divided by 8 times x. And here 9 over 8 into 12. This way. Okay. Right now. Now we can furthermore simplify this. Then we get this answer. 5y minus 45 over 8x minus 6 plus 12 into 9. Alright, so then 108 over 8 equals 0. Right, now we can simplify this. 5y minus 45 over 8x. Here we get people 48. Common denominator take 8. Here minus 48. 108 minus 48 means 60. 0. Cancel down by 5. 9. Here 12. Multiply by 8. 8y minus 9x plus 12 equals 0. 9x minus, we can furthermore multiply this by minus sign. Then we get 9x minus 8y minus 12 equals 0. Right. Next one, if this perpendicular meets the ellipse at Q. This is the Q. Right. Coordinates of Q given as 3 cos 5 and 2 sin 5. Right. Ask him to take this relation. Right. Now you can see here the gradient of this PQ. we know minus reciprocal of this. Gradient of PQ can be found difference of y coordinates divided by difference of x coordinates. Understood? Right. Then we get that answer, next answer. Right. Gradient of PQ is 908. For gradient of PQ, we can write difference of y coordinates here. This minus this 2 sine phi minus 6 by 5 divided by difference of x coordinate 3 plus 5 minus 12 by 5 equals to 9 by 8. Right now, use the cross multiplication. 16 sine 5, 48 by 5. Use this 27 cos 5 minus 12 over 5 into 9. Right. What is asking to show? Yeah. We'll take this terms to that right hand side. 27 cos 5 minus 16 sine 5 takes right hand side. Then plus 48 by 5 minus 108 by 5 equals 0. Correct, no? Then here we get minus 60 by 5 is minus 12. That means taking that right hand side, no? This is equal to plus 12. That way you can take that answer, right? Question number 5. Continuity question. Right. Continuity question. For what value of k is the function fx given this way? Continuous. That continuous word is not given at x equals 0. Right. Given fx sine 2x over x when x not equal to 0. This is equal to k when x equals 0. We need the continuity at x equals 0 and asking to find the value of k. Now, you know, in order to continuity at a given point, the graph should satisfy 3 conditions. You know, first one is at that value x equals 0, no, f0 must exist. This must exist. That existing because x equals 0 fx k. Secondly, limit x going to 0 fx must exist. That also we can find sine 2x upon x is the functional value when x not equal to 0. Now we can come to x0 from both ends. That also we can find. Third one, this limit should be equal to this. the other three conditions should satisfy for a given graph to be continuous at a given point. Yeah. F0 must exist. This one already okay because fx equals k when equals 0. That is okay. We'll find this. Right. That means limit x going to 0. When x not equal to 0, fx function is this. Sin 2x of x. Its value we can find. Multiply by 2, divide by 2. This 2 we take before. Limit x going to 0. Sin 2x divided by 2x. You know this is 1. 2 into 1 means 2. Right? This one, okay. Now this 2, okay now. Third one is this and this should be equal. F0 is k, no? K should be equal to this. That means third one, k is this F0 should be equal to this one. This one, so here we have 2. Then k equals 2. Right. Right, no? Applied math path, a thin smooth tube baby, yes, this way. Here particle P is projected with velocity root 2 ga. The radius is a. A particle q of mass simple m is placed here, q here. Mass m. Particle p of mass m is projected, is also mass m. Particle p moving along the tube collides and coalesces with the particle q at b. Right. Point B here, point A here. Right. Asking what? Find the velocity of the composite particle when it leaves the tube. I take here this level as the potential energy 0 level. Once the particle P reaches this B, I am going to find its velocity. Suppose the velocity is V. By using the conservation of mechanical energy, I am going to find that. Then at the point B, the total kinetic energy is half mv squared of this particle P. And at that moment, when it is at the point A and projected with the velocity that, the potential energy is mga, kinetic energy is half m velocity squared 2ga. In this and this you can cancel down. M also you can cancel down. V squared by 2 is equal to ga plus ga is 2ga. V equals 2 root ga this way. Then here collision takes place, and after the collision both move together as one object. Coalesce means that. Now we can find that just before the collision P moving with velocity v, Q is at rest. After the collision 2m particle suppose begin with velocity w. Now for this collision, now you can apply conservation of linear momentum rightward. Before the collision, momentum 2mw is equal to, after the collision 2mw, before mv. Q was at rest. Mm you can cancel down, w is v by 2. V is this, no? V by 2 means root Ga. So therefore, the velocity with which the combined particle begins to move is root Ga. With this velocity, the combined particle begin to move. Right, number 7, next. Projectile question. The motion of a particle projected under the gravity with velocity u inclined at an angle theta through horizontal is perpendicular to the initial direction of projection after time t. Right. This way, particle is projected with initial velocity u. Make it an angle theta. Right. Initial direction of projection is this. Right. When the particle passes this point, this direction initial and this direction become perpendicular. Given what? Our time t on this happens. If the time is t equals t. Here the time t equals 0. Now asking to find this t. People, now you can see here, if I take this as O and this as P, perpendicular to this direction, right? Perpendicular to this direction. This is the direction, tangent direction, this is the direction, perpendicular direction. Along that direction, this direction and this direction now parallel. Right? Now we apply V equals U plus AT or OP motion. Applying V equals U plus AT. What direction? This direction. That means initial direction of motion. We apply. V means final velocity along that direction. Final means at the point P. Along this direction, the velocity. You know, along that direction, its velocity is 0 because along the tangent only, it is now moving. Along this direction only, it has a velocity. Then perpendicular direction, no velocity, V equals minus 0. Then this is 0. U initial velocity in the equation of motion, that is here U along the same direction. Plus, right. People, now this A along that direction. Now you know acceleration due to gravity pointing downward g, no? Right. If this is theta, this is 90 minus theta. Then along this direction, the component of this g going to be g cos 90 minus theta. The theta 90 minus theta, g cos 90 minus theta. That is g sin theta. That acts the direction opposite to the equation of motion we apply. Therefore, it is minus, right? Minus g sin theta times t. Then you can subject t by this. You get this answer. U over g sin theta. This way. Number 8. Relative acceleration. A smooth light pulley is fixed to a smooth fixed plane. This plane is fixed one. The inclined plane is a fixed one. Wedge is fixed one. It doesn't move. Right? It doesn't move. Alpha here. This way I draw the particle P. Mass is equal to 2m, no? Tension. The other end we have this way particle Q. Tension T. Q has the mass m. Let us take this acceleration is simple left. Q has the acceleration in the other direction, simple left. Then if we apply F equals ma, number 1, 4 p, this direction, 2mg sin alpha minus t. 2mg sin alpha minus t. Here t. 2mg sin alpha means the component of weight of this t. 2mg sin alpha minus t equals 2mf. Number 1. Secondly, for q this direction, t minus mg sin alpha equals mf. Number 2. Now, by solving these two equations, we can find 1 plus 2. T minus t you can cancel down. 2mg minus 2mg sin alpha minus mg sin alpha. Mg sin alpha equals 3mf. M you can cancel down. F is equal to g sin alpha over 3. Right. Now we can find t by number 2. Right. By 2 you can find t. By 2 equals mg sin alpha plus m times f g sin alpha by 3. Then we get 2mg sin alpha, mg sin alpha, or mg sin alpha divided by 3. This we get. Number 9, work power energy. There you are given a car with constant velocity v meters per second along a level road. This is the car. With velocity v meters per second, the constant resistance is capital R with constant power h kilowatt. Tractive force is F, you know H equals Fp, no? F can be calculated H into 10 to the power 3 divided by V, right? Tractive force is H upon V. H given is kilowatt, then this is the number of watts divided by V. So that resistance is this much. You know, when the car moves with the maximum velocity, tractive force is equal to resistance. Therefore, tractive force is given by this, no? So, therefore, R equals this, H into 10 to the power 3 over V, newtons. Right. Then the car moves down along a road incline at an angle alpha to the horizontal with the velocity of V by 2R, right? Now, the same car right. Inclination of the road is now alpha. Yeah, moves down with velocity V by 2. The weight mg, its component is sine alpha now, mg sine alpha. Power h kilowatt. Then the true force is what, people? It's going to be h over v, no? Still the power is h kilowatt, velocity is v by 2. Right, then tractive force is this much. Same power h kilowatt against the same resistance R. R acting this way. So the acceleration of the car is this much. The mass is same. Now we apply F equals ma for the car, this direction. Mg sine alpha plus capital F minus R. Mg sine alpha plus F minus R equals m a. A is the acceleration. A is the acceleration. Now we can simplify this. Thereby you can take the answer. At mg sine alpha plus f is 2h into 10 to the power 3 upon v. R is that minus h into 10 to the power 3 upon v equals m times a. Right. Right, no? Then simplifying this 2, we get h into 10 to the power 3 divided by v. Meantime, divided by m. M come in here. Dividing both sides by m, this is g sine alpha. Now right hand side only a remaining. That is the acceleration. Right, then the answer come in, no? Therefore, the acceleration A is h into 10 to the power 3 divided by mv g sine alpha. This is acceleration. Question number 10. Vector question. In the usual notation, the Persian vectors of the points A, B, and C are given this way, respectively. Lambda mu are real constants, where O is the origin. OA, BC represents a trapezium. Here OA and CB are parallel and CB equals half OA. All right. Right. Here O, A, C, B. Given that O, A, and C, B parallel, and also C, B equals half OA. Point A has the coordinate Persian vector 2y plus 4j. B 4I plus 4j. Right? C lambda I plus mu j. You see, right? And now C to B direction, O to A direction. People parallel, same direction. CB is equal to half OA. Therefore, by this relation with the diagram, we can write C to B vector should be equal to half OA vector. By using this all information together, we can write like that. Okay, right. Now we can write CB vector is equal to half OA vector. CB vector we can write Persian vector of B minus Persian vector of C. Persian vector of B is 4i plus 4j minus Persian vector of C lambda I plus mu j. Half OA vector is 2i plus 4j, no? 2i plus 4j. Correct, no? Persian vector of B 4i plus 4j minus Persian vector of C lambda is this way. Then I can simplify here. 4 minus lambda I 4 minus mu j, there I plus 2j. Equate the coefficients of I on both sides. Here 4 minus lambda equal to 1, lambda equals 3. J 4 minus mu equals 2, mu equals 2. Lambda mu we found. Lambda 3 mu 2. If AOC angle, this is theta. So that cos theta is this much. Then I can write this way. OA vector dot OC vector we can write OA vector modulus into OC vector modulus cos theta. This we can write. OA vector is 2i plus 4j for C vector lambda I plus mu j. Lambda 3I plus mu 2j equals OA modulus. OA vector is this, no? Its modulus means I coefficient squared plus j coefficient squared root 4 and here 20 root. OC vector is this 3 squared plus 2 squared 9 plus 4 root 13 cos theta. Left hand side, this product you can take, multiply I coefficients 2 and 3 6, 4 and 2 8. Here we can write 4 into 5, no? 2 root 5 root 13 cos theta. Here 14, when you divide by 2 we get 7. Root 5 root 13 is root 65. Therefore we get cos theta 7 over root 65. 7 over root 65. Right. This way we can finish for this discussion.